If you're a web developer, you know this feeling. Your app looks great, the logic is totally solid, but then you hit refresh and you get nothing, just a blank screen. So you open the console and there it is, that big red angry error blocked by CORS policy. Okay, let's finally get to the bottom of this and demystify one of the biggest headaches in web development.
Right? This is the exact scenario that drives us all crazy. You've got your front-end app. It needs to get some data from your API. The API is definitely up. You can hit the endpoint with a tool like Postman or even curl, and you get a perfect, beautiful response back. But in the browser, nope, fails. Every single time. So what's happening? This isn't a bug in your code, and your API isn't broken. So what gives?
And here we go. This is the heart of the issue right here. Your request works in Postman for one simple reason. Postman is not a web browser. It's just a tool. It makes raw HTTP requests directly to a server, and it couldn't care less about browser security rules like the same origin policy. The browser, on the other hand, lives in a dangerous world. Its number one job is to protect its user, that's you, which means it has to follow a very strict set of rules. And that brings us to the hero, or let's be honest, sometimes the villain of our story, the same origin policy. That CORS error you're seeing isn't the browser just trying to ruin your day. It's the browser doing its job. It's acting like a security guard to protect user data. The same origin policy, or SOP for short, is one of the oldest and most important security ideas on the web. Basically, it says that a script running on one website can't just reach out and grab data from a totally different website. And thank goodness for that. Without this rule, any shady website you visit could use your logged-in session to silently make requests to your bank or your email and just steal your private information. The SOP puts every website in its own little sandbox. So, what does the browser mean by an origin? Well, it's really specific. An origin is made of three parts: the protocol, so HTTP or HTTPS, the host, like example.com, and the port number. If any one of those three things is different between two URLs, the browser considers them cross-origin. And yeah, that means even app.example.com and api.example.com are from different origins because the host names don't match exactly. Now, here's the really important part. The SOP doesn't actually block everything. You can still submit a form to another domain. You can still embed an image from another server. What it strictly prohibits by default is reading the response from a cross-origin request. So your script can send the request, and the server will even process it, but the browser just steps in like a bouncer and refuses to let your JavaScript code see the answer. Okay, so if the same origin policy is so strict, how does anything on the modern web even work? How does a React or Vue app talk to its API on a different subdomain? Well, this is where cross-origin resource sharing, or CORS, finally enters the picture. It's the official, built-in way to safely loosen up the same origin policy. This is probably the most important thing to get about CORS. It is not an error. It's not a firewall on your server. Just think of it like a permission slip. It's a special set of HTTP headers that the server sends to the browser. It's the server telling the browser, hey, browser, it's cool. I give that other website permission to read my data. The server grants the permission, the browser enforces it. But what about requests that could, change things on the server, like a put or a delete? Or what about requests that have custom authentication headers? For these more dangerous types of requests, the browser gets extra careful. It doesn't want to just blindly fire off a request that could delete data without making sure the server is ready for it. So how does it check first? It uses this really clever process called a preflight request. Before your browser sends the actual request, it first sends a tiny, harmless options request. It's like the browser is politely asking the server, hey, I'm about to send a put request from this origin with an authorization header. Is that okay with you? If the server responds back with the right permission headers, then the browser goes ahead and sends the real put request. If not, the whole thing is called off before your data is even sent. And this chart breaks down when that happens. Simple GET requests, they usually don't need this preflight check. But as soon as you use methods like put or delete, or if you add any custom headers for things like auth tokens, boom, the browser automatically triggers this preflight handshake. This is exactly why you sometimes see two requests pop up in your network tab for a single line of code you wrote. Okay, so we've got the theory down. Let's get practical. When you see that CORS error, your first instinct should be to check the server configuration. The problem is almost always on the back end, and it's usually one of these four common culprits.
First up, the most basic. The access control allow origin header is just completely missing from the server's response. Second, the header is there, but the value doesn't exactly match your front end's origin. A typo or a different subdomain is all it takes. Third, a really common one. The server is sending a wildcard, star, to allow anyone, but your request is also sending credentials like a cookie. And fourth, the preflight fails because the server hasn't explicitly said that it allows the HTTP method you're trying to use, like put. I really want to double down on that third point because it's so critical for security. Browsers will always block a request that tries to combine a wildcard origin with credentials. It's a built-in safety net. If you need to send cookies or auth headers, your server must respond with the specific, full origin of your frontend. No wildcards allowed. All right, let's put all this theory into practice. We're going to walk through a real-world debugging scenario to see exactly how you can find and fix a CORS issue in just a few minutes.
So, here's the situation. A user is trying to check their transaction history, but the data never shows up. They just see a loading spinner, forever. Your spidey sense is tingling. It's got to be a CORS issue. Okay, first and most important step. For a second, ignore the console tab. Go straight to the network tab in your browser's DevTools. The error message in the console is usually super generic for security reasons, but the network tab, that shows you the entire raw conversation happening between the browser and the server. That's where the clues are. Now, in the Network tab, you're looking for a request with the method options. And there it is, lit up in red. It failed. This is our smoking gun. Because this preflight request was rejected, the browser never even bothered to send the actual GET request to get the transaction data. So we click on that failed options request and look at its headers. Under the request headers, we see the origin the browser sent, app.production.com. Makes sense. But then we look at the response headers that came back from the server, and we see access control allow origin https:/app.staging.com. And there it is, a classic copy-paste mistake. The production server is still using the staging URL in its configuration. And just like that, the fix is crystal clear. This has nothing to do with the front end. The back-end team needs to update the server's CORS config to send the correct production origin. There is no amount of front-end wizardry that can fix a server sending the wrong permission slip. So, if you only take one thing away from all this, let it be this. The server doesn't block anything. The browser does. The server's only job is to provide the right access control allow origin headers. The browser then reads those headers and decides if your JavaScript is allowed to see the response. And this all points to a bigger, really cool idea. This whole dance between the browser and the server is a perfect example of the web's core design. It's not a system built on some central authority telling everyone what to do. It's a system built on a decentralized model of trust, where every single server gets to declare who it trusts, and our browsers act as these impartial enforcers, all to keep every single one of us safe online.